Hello students. So today we will start our unit 3 and which starts from the topic successive differentiation. Okay? It's a very important topic and very interesting topic also for the derivative of the function. So let us see what is the meaning of successive differentiation. Okay? So initially in your high school level we have already learned that to find the derivative we need a function, right? So suppose y equals to fx is a function where this x is independent variable and this y is dependent variable, right? Under the function f. So suppose y equals to fx is a function, and suppose we know that this function is differentiable with respect to x. Okay? Suppose somewhere you find it like that y equals to fx is a differentiable function with respect to x, right? So if somewhere you find this, that the function y equals to fx is differentiable with respect to x, that means we can find the derivative of this function with respect to x, isn't it? If a function is differentiable, then what is the meaning of this? That easily we can find the derivative of the function, right? So we have got those symbols that if this is a function of differentiable function of x, then we know therefore the first derivative of the y with respect to x can be denoted by y1, right? Or you can denote it by y dash, or you can denote it by dy, or you can denote it by dy dx. Okay, or you can denote it by f dash x, or you can denote it by, this is the definition of the function, that limit h tends to 0 f of x plus h minus fx by h, right? This is what the definition of derivative, because already we have learned in our higher level. If you forgot this, then I recommend you please go back to this concept, that limits and derivative, then come back to this question. Okay? So if y equals to fx is a differentiable function with respect to x, then we can find the derivative of the function with respect to x, and these are the symbols that we can use to determine the first derivative of the function with respect to x. Okay? So it can be denoted in this. Okay? Now next question is, the derivative of a function is again a function, isn't it? For example, if you take y equals to x cube, then we know that this function is differentiable with respect to x, right? So we can find the derivative of the function with respect to x, then we get 3x squared, and you see this is again a function, right? So we know derivative of a function is again a function. Okay? So in this case you see, first function is y equals to x cube, then after differentiation we get this 3x square, and then you see this 3x square is again differentiable, isn't it? Because we can again find the derivative of the function 3x square with respect to x, right? So if we have to find that if y equals to f dash x is a differentiable function with respect to x, then again we can write this y1 will be replaced by y2, and this y2 denotes the second derivative of the given function y equals to fx. Okay? So this can be denoted by y2, it will be y double dash, then it will be d2y, it will be d squared y dx squared, and it will be f double dash x, and it will be what? No need to write it, obviously. Yeah. You can stop it, because this is the definition of differentiation, right? So this is the way how we can denote the second derivative of the given function y equals to x, right? Now here you see, if you find d square by dx square, then you will get 6x, and you see this 6x is again a function which is a differentiable function with respect to x again, right? So here if you find this second derivative is again a function of x, then we can find the derivative of the function. And you see, if you get again y equals to average x is a differentiable function with respect to x, then y3, then it is denoted by y3. y3 means what? The third derivative of the function with respect to x. Okay? It will be y dash 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 d3y. It will be d3y dx3, and it will be f dash 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 x. Right? And in this way, we can find the nth derivative yn or yn or dny or dny dxn or fnx. Right? This represents the nth derivative of the function with respect to x, and this n is definitely a natural number. Okay? And this is the concept of successive differentiation. That means if you are given a function y equals to fx, then you have to find the nth derivative of the function. This is what you have to do in this topic. Okay? Successive differentiation का मतलब क्या है? अगर आपको किसी भी फंक्शन दिया गया है y equals to fx, that means if you are given any function y equals to fx which is differentiable with respect to x, then your job is to find that the given what will be the order of differentiation of the given function. That means suppose here you see suppose your function is y equals to x. Use this example. Then first you can find first derivative, then you can find second derivative, then you can find third derivative of the function, which is nothing but x. Right? So this is the concept of successive differentiation. That means you have to find the general form. Right? That means here we are not dealing with this type of functions. Right? Some standard functions are there. We are interested to find the nth derivative of those functions by using the concept of successive differentiation. Then by using those results or those formulas or those nth differentiation or nth derivative of these functions, we will solve some problems. Okay? So let us see what are those results, standard nth derivative of the function. So before that, pause the video to note it down. So these are the some standard nth derivative of some particular function, standard nth derivative. Okay. So let us recite one by one. If y equals to ax plus b whole thing to the power n, then yn equals to a to the power n into m minus 1 into m minus 2 into dot dot into m minus n plus 1 into ax plus b whole thing to the power m minus n. Okay. Now you see, if your m is greater than m, okay, I will do it later. Improve I will do it. Next you see number 2. If y equals to 1 by ax plus b, then yn, that means nth derivative. Right? Your function is given that y equals to 1 by x plus b, and you have to find the nth derivative. And these all are standard results. Okay? So nth derivative of yn means nth derivative of y equals to minus 1 to the power n into a to the power n into factorial n whole thing divided by ax plus b whole thing to the power n plus 1. Next number 3 you see, if y equals to log of ax plus b, then yn equals to minus 1 to the power n minus 1 a to the power n into factorial n minus 1 whole thing divided by ax plus b whole thing to the power n. Next number 4, if y equals to e to the power ax plus b, then yn equals to a to the power n into e to the power ax plus b. Next number 5, if y equals to sin ax plus b, then yn equals to a to the power n sin n pi by 2 plus ax plus b. And then next, if number 6, if y equals to cos ax plus b, then yn equals to a to the power n cos n pi by 2 plus ax plus b. Okay? So remaining two results are there. So let me write. So before that, pause the video, note it down. So these are the two remaining results. Number 7 is, if y equals to e to the power ax plus k into sin of bx plus c, then yn means nth derivative of y will be a square plus b square whole to the power n by 2 into e to the power ax plus k into sin bx plus c plus n tan inverse b by a. And if number 8, if y equals to e to the power ax plus k into cos bx plus c, then y n, that means nth derivative of the function y equals to a square plus b square whole to the power n by 2 into e to the power ax plus k cos bx plus c plus n tan inverse b by a. Okay, so try to keep these 8 results in your mind, so that you can apply those results frequently to solve the problem regarding this successive differentiation. Okay, so let me prove those results one by one. Okay, so before that, pause the video and note it down. So let us prove this first result. So prove. So remember, if any mathematical statement starts from if, then you have to start this statement by let. Okay. So let y equals to ax plus b whole thing to the power n. Okay. So you have to find the nth derivative of the function y. So let me first y1, then first derivative, then second derivative, then third derivative. Okay. So give it equation number 1. You have to write differentiating 1 with respect to x, we get what we get y1 equals to, you know the derivative, right? X to the power n, you know, if y equals to x to the power n, then the derivative of dy dx will be n x to the power n minus 1, isn't it? You should know it because we have already got those results in your high school level. So the derivative of this will be x to the power n, so it will be m ax plus b whole thing to the power m minus 1 into derivative of this. So ax plus b, the derivative of this function will be a only, right? So I can write this one as a to the power 1 m into ax plus b whole thing to the power m minus 1, isn't it? Now again differentiate this one with respect to x, we get y2. Y2 will be what? M, then you will derivative this, so it will be we have to derivative this one, right? Or you can write it like that, number 2. So again you write differentiating 2 with respect to x, we get y2. Y2 will be what? A n is constant, so you can keep it like that. Then derivative of this will be what? X to the power n, so m, it will come here, so it will be m minus 1 ax plus b into m minus 1 minus 1 into a, isn't it? Because this a n is constant, so we can keep this constants here. Then derivative of this will be this into this to the power this minus 1. So this to the power this minus 1 into derivative of this. So derivative of this will be a, right? So now if we manipulate it, you see a into a, you will get a square. Then m is there. Then m minus 1 is there. Then it will be ax plus b whole thing to the power m minus 2. You can give it number 3. Again differentiating 3 with respect to x, we get what we get y3. So y3 will be what? You can derivative this. These two terms are constant, right? A square into m minus 1. These three terms are constant. So you can keep these terms here. So a square m into m minus 1, right? Now derivative of this will be this into this to the power this minus 1. So again it will be m minus 2 into ax plus b whole to the power m minus 2 into minus 1 into the derivative of this, so it will be a. So I can write it like that: a square into a will be a cube, then m into m minus 1, then m minus 2, right? Then ax plus b whole to the power m minus 3. Sorry, it will be m minus 3, right? Because m minus 2 minus 1 will be m minus 3. Now you see, if you can find the similarity of the result, you will get when y1 is there, then the power of a will be 1, then the number of terms here with m is 1, then here m minus 1, right? When here is 1, the power of a is 1, number of terms here is 1, and it will be m minus 1, right? Similarly, when it is 2, then here the power of a is 2, the number of terms with m is 2, then here it will be m minus 2, right? When it is 3, then the power of a is 3 and the number of terms with m is 3, then here it is m minus 2, right? So if we can generalize those results, we write proceeding similarly, we get what we get yn, nth derivative. Now what will be nth derivative? You see, when it is 3, then the power of a is 3. So when it is m, the power of a will be m, right? Now you see, when here is 1, then the number of terms with m is 1. When there is 2, the number of terms with m is 2. When there is 3, the number of terms with m is 3, right? So when it is m, the number of terms with m will be n, right? Now you have to say another thing. When it is 2, then it will be m minus 1. When it is 3, so it will be last term will be m minus 2. That means 1 less than this quantity, right? When it is 2, then it will be m minus 1, 1 less than 2. When it is 3, then the last term is m minus 2, that means 1 less than 3. So it will be m into m minus 1 into m minus 2 and the last term will be m minus 1 less than n, so it will be n minus 1, right? And the last term is what? ax plus b whole to the power m, it is n, so it will be m minus n, right? Now we can write it yn equals to a to the power n, m into m minus 1, m minus 2 m minus n plus 1 into ax plus b whole to the power m minus 1. Now it is done. The result is done, right? Now one thing you have to remember that now yn will be, now you see, when m is greater than n, right? When your m is greater than n, you have to find the nth term. When this condition is imposed, then m is greater than n. Now you see, I can write an this can be written like that. This is the result, or you can generalize this result like that. You see, an m into m minus 1, m minus 2, m minus n plus 1. Then what will be the next term? Next term will be 1 less than this term, so it will be m minus n. The next term will be m minus n minus 1, and in this case I get 3 to 1, and the last term will be ax plus b whole to the power m minus n, and I have to divide this whole term by this quantity, and this quantity is m minus n into m minus n minus 1 3 to 1. ध्यान से देखिए लाइन, अगर आप लोगों ने परम्यूटेशन और कॉम्बिनेशन एचएस में बहुत अच्छे से पढ़ा है, तो ये जो कॉन्सेप्ट है वो हम लोगों ने यहाँ पे यूज किया था, राइट? वी हैव ऑलरेडी यूज्ड दिस कॉन्सेप्ट इन केस ऑफ परम्यूटेशन and combination. Okay, so what I have done here, you see the terms are decreasing by 1. if you can follow the tree, then you see 1, then m minus 1, that means 1 less, then m minus 2, that means 1 less. That each terms are decreasing by 1, right? So what I have done, I am just decreasing, I am just continuing the process till I get the quantity 1. Okay? So as I multiply this extra quantity with this term, so I have divided this term also, because I can write, you see, I can write x equals to 2x by 2, right? If I multiply, and that means with any quantity I can multiply and divide by the same quantity, isn't it? Because x can be, if you multiply the x by 2, at the same time if you divide this by 2, then obviously you will get x, right? So here what I have done, with the same quantity I have multiplied as well as I have divided this quantity, right? Now you see, what is this term? Is yn equals to, it is a to the power n. Now this quantity starts from 1 and ends with 1. You see, this term starts with m and ends with 1. So it will be what? Factorial m. Right? And this term starts with m minus 1 and ends with 1. So it will be factorial m minus n. Right? And this is what? Ax plus b whole thing to the power m minus 1. Okay? Now let me reach this part. Let me reach this upper part, because I need some place to solve this one. Let me reach this part. Now you see, yn equals to, yeah, it will happen when m is greater than n, right? So it will be what? A to the power n factorial m by factorial m minus n and ax plus b whole to the power m minus n if m is greater than n. Why? Because if m is not greater than n, then this factorial m minus n will be undefined, right? Now next case will be if m is equals to n. So you just put m equals to n in this result. You will get what? It will be a to the power n. Then it will be what? Let me do here a to the power n. Then just put m equals to n here. It will factorial n. Then it will be n minus n. Then it will be ax plus b whole thing to the power n minus n. Right? So it will be what? A to the power n into factorial n, because n minus n is 0, so we know factorial 0 is 1, right? And n minus n is again 0, so we know anything to the power 0 is again 1. So this quantity is 1 and this quantity is 1, so we are left with this quantity. So it will be n to the power n into factorial n when n is equals to n. Now if n is less than n, then the answer is 0. Why it is 0? Let me take one example. Y equals to x cube, and in earlier case we have seen that we can differentiate this function 3 times, right? Now here you see this 3 is your m. My m is 3, right? Now if you take your m is 4, that means my case is m is less than n. So here you see my m is definitely less than n, because 3 is less than 4. Now find y1, you will get 3x square. Then find y2, you will get 6x. Then find y3, you will get 6. Then find y4, you will get 0. Right? So that is why it is 0. Because when your power is less than the number of differentiation, then the result is always 0. Because your power is 3 and you are going to differentiate this function 4 times, so definitely you will get 0. Right? So this is the standard result. So try to understand the proof. Try to practice the proof. Okay, we will prove the next result in our next class. Okay, so thank you.